Hi guys, good morning. I hope you're able to hear me. Can anyone please confirm? Okay. Okay, so in the last session, we have seen yesterday type 2 implementation. I didn't send this note. I'll send it today. Okay, so I wanted to send all together since it was having this partitioning. Okay, so how we can handle this yesterday type 1 implementation that we came across it in order to have or in order to maintain historical data in the target, we can go for yesterday type 2 implementation. So yesterday type 2 is saying if there is a new record in the source, then you have to go and insert the data into the target. And again, if there is an update in the source, then again you have to go and insert the data. But whereas in a yesterday type 1, you can just maintain the current data by using yesterday type 1. But when it comes to yesterday type 2, we are going to handle historical data. How we can do it, that we came across it. Now, I wanted to talk about this partitioning. So partitioning is more on a theory, 95% is theory only. Okay, so even if you wanted to change this partitioning types, you can change with just 2 or 3 clicks away. Okay, so if you wanted to improve the performance of the data flow, there are 2 different approaches are there to optimize. One is broadcasting that we already discussed about it, how we can use the broadcasting. And apart from that, we have a partitioning also. Okay, so how exactly we can handle it? How we can take this partitioning or what are the different types of partitioning? There is a chances to ask a question, what are the different types of partitionings are available in the data factory? Or they may ask which kind of partition is going to improve the performance. So it all depends on the requirement. We can choose the partitioning type. Okay, so first try to understand what are the different types of partitioning we are having and how we can use that partitioning. Okay, I have a already data factory. Okay, if I go here, so there is a partitioning, set partitioning. This partitioning, how exactly it is going to do is, there are 3 different types of partitioning, right? I have given, did I give? Okay, so current partitioning. What this current partitioning is going to do is, whatever the number of blocks are there in the data source, that many number of partitions are going to be created. Okay, so you are taking data from the ADLS. We know that. When you upload the file is going to be divided into blocks. From the beginning, we are saying the same thing, right? So when you have some file like employee.csv file, when you upload this file into the Azure Data Lake Storage Center, the file will be divided into multiple blocks. Okay, so let's say, for example, if the file is having 5 blocks, then it is going to create a 5 partitions if we have a current partition. So current partitioning is used to create a partitions based on the number of blocks in the data source. If the data source is having 5 blocks, and it is if the file is having 5 blocks, then it is going to create a 5 partitions. Okay, so example, I'm just going to give an idea here how we can take it. Let me take Excel. I'm just taking an employee numbers here, 101, 102, 103, okay, and 105. Let's take 10 employees, I'm just taking. So employee names are this. Okay, employee number and email. So this is the data source and this is the data source in the ADLS. The file name itself, I'm just giving here employee.csv. Okay, so this is the name of the file that we are having for this. Okay, so if when you upload this file into the Azure Data Lake storage into, not this one, let me say, so let me say here is, just imagine this is the some source. Okay, so just imagine your on-prem data source. Our source is on-prem, just imagine. When you have a file in your file storage, that is what we have done, right? When we go here, I have a employee.csv file. When I upload this employee.csv file into the Azure Data Lake storage N2, then that means you are uploading into the Azure Data Lake storage N2. When you upload this file into Azure Data Lake storage N2, it is going to create a partitions in the Azure Data Lake storage N2. Okay, so let's say for example, just for understanding, I'm just taking 3 records into one partition. Like that, I'm just taking 3 partitions. I wanted to create these records. Okay, so first 3 records will be there in the first partition. Okay, so I wanted to say this is partition 1. Up to 103. Then I'm just taking next 3 records into here. Just for understanding, I'm just taking this. Next 4 records I'm just taking into another partition. Just imagine 3 partitions are created in the Azure Data Lake storage N2. Partition 1. So this is partition 2 and this is partition 3. So that means when you upload the file into Azure Data Lake storage N2, the file is going to be divided into multiple blocks. Okay, so multiple blocks. Block 1 is not partition. Let me say it is a block because partition comes into the data factory. This is a block 2 and this is a block 3. Okay, so 3 blocks are there. Just imagine. Okay, so every block size is having 4 MB by default, and if you want to increase or decrease, you can do it. So it's a depends on the requirement. Administrators are going to handle it. You don't need to worry about it. So here I'm taking this 4 MB size I'm having here, and 4 MB is there here, and 4 MB is there here. Okay, and I wanted to read the data from here. What you're going to do, you're going to use the Azure Data Factory to read the data from here. So when you try to read the data from the data factory, when you try to read the data from data source by using data factory, we have a optimized option called partitioning, right? There are 3 different types of partitioning we are having. One is current partitioning. So current partitioning is going to say what it is saying. If my file is having 3 blocks, if my file is having 3 blocks, then 3 partitions will be created in the. I'm just taking a copy of this, pasting it again. So here it is going to be ADF. So when you go for ADF, what happens is it is going to create a partitions. Partition 1, partition 2, and partition 3. So 3 partitions are created. So on what basis it is created? Based on the number of blocks in the data source, that many number of partitions are created here. Okay, so every partition will execute in one node in a separate computer. I mean to say parallel processing, right? Because the reason why we are doing data transformation in the data factory is because to implement parallel processing. This will be done by one person, this will be done by one other person, and this will be done by another person. Okay, so 3 partitions are created based on the number of blocks. That is what it is, the current partitioning. Based on the number of blocks in the file, that many partitions will be created by ADF. Example, if the file has 10 blocks, then the data will be loaded into 10 partitions. In how many partitions the data is loaded? Because I'm having 3 blocks here and 3 partitions are getting loaded into the data source. So that is how it is going to be happen. So this is a current partition. Okay, so by default, data factory will take care about it. It depends on the number of blocks. Then what happens if we have a file, if we have a table? If a data source is table, then definitely you are not going to have it. Okay, so how you can handle it? The current partition is going to do only if the file is divided into blocks, then we can have that many number of partitions. If the file is not divided into blocks, ultimately, if you can take the data from here directly, if you take the data from here to here directly, then what is missing here? Blocks are missing. Everything is going to be there in a single partition. Just imagine if the file size is 5 GB, if your RAM is not more than 5 GB, then definitely you cannot load the data into the data source, right? So RAM is going to be, I mean to say, in memory, memory issues you are going to get. So to avoid that, basically we don't load the data into the single node, the entire data. Because of that reason, we are bringing the data into the Azure Data Lake Storage Center. From the Azure Data Lake Storage Center, we are bringing into the Azure Data Factory. So this is how it is going to be happen. Okay, this is about the current partition. Okay, so if data source is a table, then this current partitioning is not going to work for you because all the data has to be loaded in a single partition. That is one problem. Another problem is I don't want to go for the blocks, whatever the number of blocks are there here, the same number of partitions I don't want to create it. The reason is, the reason why I wanted to take this is, even like if I go for current partitioning, there is a one problem. The problem is, if you remember, we talked about the broadcasting, right? So if you have a too many partitions, okay, so too many blocks, I'm just going to say this, I'm just extending. Okay, so something like this. If you have a block n, let's say 100 blocks. Okay, so that many number of blocks are block 1 to block 100, I'm having it. Okay, so I'm just taking out this data at this point of time. Just imagine there is some data for this blocks. So data is distributed across the 100 blocks because my file size is very huge. Just imagine. Okay, so if the number of blocks is 100, then definitely 100 partitions are going to be created. Okay, so apart from this, we're also going to have every employee is going to work in some department, right? So department related stuff also is going to be there. That is also going to be divided into multiple blocks and that many partitions are going to be created. Let's say, for example, 100 blocks are going to join with the department data. Again, if I go with that, okay, so I'll do one thing. This is partition 100. Okay, if you have a department details here in the data source, then you need to have a one more partition for the department. Okay, so I'm just taking here department number, department name. Okay, so department number is, let's say 10 I'm taking. So department DPT1, I'm just saying. Otherwise, let me say department number 10. I'm not giving the name here. You can take any name. This is 20. Okay, so let me take this. Okay, so here in this particular place, I'm not showing the department number. Okay, so you can have a department number in this particular place. Okay, so department numbers may be anything. Otherwise, let me take a, I'll do one thing so that you can get better clarity. Let me say DPT number. Ten 30, 10, 30, 20, 30. I'm just randomly taking some numbers here. 10, 10, 30, 20. So like this, you have a department numbers. Okay, so here also it is going to have it. I'm just taking this entire thing, copy, paste it. That's fine. Just for understanding, I'm just doing all this stuff. Okay, so department number 10. If I wanted to get the department name in my output is expecting the output is expecting something like this. Okay, so I wanted to keep the data something like this. I need employee number. This is the expected output, employee name, department number, D name, department name. So department name is not available in the employee table. So this is your expected output in the target. Okay, so this column is coming from the employee table because employee number I'm having it. So I can use that. I can use that employee number. And employee name also is coming from the employee name. And department number is coming from the department place. I can use this. And department name is not coming from the same place. Department name is coming from some other partition. So just imagine this partition is okay. So this is the department number partition. Let me make this as a 101. Okay. 101. Okay. Total 100 partitions are there for employee table and one partition is for the department table. So what happens is when you join this record has to come to this partition and need to see the data for appropriate department number 10. So 10 is there, so 10 details are going to get. So then output is going to get for that particular record. And department number 30, what is the value? It is going to take department number 30. What is the name of the department? It is going to get it. Okay, so department number 30 is going to get for this particular place. So something like this you are going to get. And what is the department name for this is DPT-10 is the department name. So department name is coming from the department table. Okay, so just imagine this entire table is there in a single partition because I'm having less number of records, or there is only one block. So since there is only one block, it is taking only one partition. Just imagine. So every record is going to hit this partition to take the data. So that means, so shuffling is required. Before joining this data, shuffling is required. So once you have a shuffle, then only it is going to apply the data combining. So because of that reason, what we discussed is, instead of having this particular partition in a separate node, bring this particular, this just broadcast this partition data. So when you broadcast it, then all this data is going to be available in this partition. Is this data available in this partition? And this data also is going to be available into this particular partition. Okay, so since we have a less volume of data, then you can do it. If you have a more volume of data, then you cannot do it. That's not going to be best practice. Okay, so you can use the current partitioning. In this particular case, when you use the current partitioning, make sure to use this as a broadcast. Okay, so broadcast side, you have to keep this so that the data will be available within the same node. So no shuffling is required, no movement is required from one partition to another partition. So data itself is going to be available here. So this is suitable to use only if you have a less volume of the data from one side. Okay, when you join the two tables, one table should have a less volume of data, and other table you can have a multiple volumes of, multiple partitions of the data. Just imagine, at any cost, if your department data is also there in 10 partitions, that means if it is there in a 10 blocks, then 10 partitions are going to be there, right? Partition 1, partition 2, like this, 10 partitions will be there. Okay, so then this particular data is going to compare with all the partitions. It's going to compare with all the partitions. That is the problem. If you go with the current partition. Okay, so it has to go, even if you use the broadcast, what happens is 10 partitions are going to be there in each and every partition, means that again, that is going to be a problem for that, because data is going to be loaded in the RAM, not in the hard disk. So because of that reason, you can handle the partitioning from your side if you have this kind of situation. So when you go for other partitioning, what are the other different partitioning we are having that you can see here? Single partition. So single partition is going to be happen when you read the data from the table, then definitely it will go for single partitioning if you use the current partitioning. Or if you have too many files or too many blocks, but block sizes are very smaller sizes. Okay, so if you wanted to bring them into the single partition, you can just bring it to the single partition. So just observe how exactly it is there in the data factory. You can see there is a single partition. So single partition means all the blocks will be coming into single partition. If you take this an example, this entire data is going to be there in a single partition. Let me say it is a current partitioning. Okay, let me duplicate this. So what happens is everything will be in the single partition. Okay, so again, I wanted to do this side also. Okay, so what happens is, whatever the number of blocks you're having, it doesn't care about it. How many number of blocks you're having in the data source. All these 100 blocks are going to be treated as a single partition only. Okay, so this will be recommended only if the size, if you have a less number of blocks and if you have a less volume of the data, then you can go for that. If at all, if it is having more volume of data and more number of blocks, then it's not recommended. So that means you can have a single, all the data into the single partition itself. Example, how exactly it is going to behave is this one. And when you come to the set partitioning, then here is the situations. So when you go for set partitioning, you can set your optimization from your side. If you give a chance to Data Factory will take care about it. If you don't give a chance to Data Factory, then you have to take care from your side. So in interview, there is a chances to ask about this partitionings. What are the different partitionings are there? What is round partition or hash partitioning? Okay, so you can face this kind of questions. Okay, if at all if you face, then explain about this first round robin. So it is going to evenly distribute the data across the partitions. Okay, so order of the data is also different. When you go for the current partitioning, whatever the order is there, order is there in the blocks, if you say whatever the order is there in the block 1, the same order we are going to have in the partition also. Here also the same order you have. But when you go for a round robin partitioning, how exactly it is going to be behave, that I wanted to say. Round robin. Just taking out this. Not 100 partitions I wanted to take. So 3 partitions are there. 3 partitions are there here. And I wanted to go for only 2 partitions from my side. Okay, so I wanted to create only 2 partitions. There may be multiple partitions. So just imagine 10 partitions or any number of partitions. But I wanted to apply partitioning from my side. I wanted to control the number of partitions. If you go for current partitioning, if the file is having 3 blocks, then 3 partitions will be there. But in my case, here I wanted to create 2 partitions. Okay, so you're not going to create one partition when you go for the set partitioning. You cannot keep one here. One is not a minimum partition. If that is the case, you can directly go for single partition. So 100% more than one you have to specify. So minimum 2 partitions you need to specify if you go for the round robin partitioning. Okay, so the number of partitions you can control here. How many number of partitions you wanted to control? If my data source is having 3 blocks, if I go for current partitioning, 3 partitions will be there, but I wanted to keep only 2 partitions. So round robin partition, I'm going to do it here. Okay. So if it is round robin means the data is going to be evenly distributed. The data is going to be distributed evenly across the partitions. So first record 101 will come to here. Then name is A and the part number is 10. And 102 will come to here. Let me take a copy. Paste it. 102 will come. And 103 will go to here. And 104 will come to here. And 105 will go to here. 106 will come to here. 107 will go to here. 108 will come to here. 9 will go to here. And 10 will come to here. So this is how it is going to be here. So two partitions are there. Right? This is partition 1 and partition 2. So two partitions are there here. So it's not following same order. The order of the data is not same because number of partitions are different. And this is a round robin partition, how exactly it is going to do it. So evenly the data is going to be distributed. Okay, so and when you join the data again, you can, if you want to make it a broadcast, you can make a broadcast. I can keep the data within the same partition. Okay, so I mean to say this data also is going to be divided into two partitions. Okay, so if you go here, let me take join transformation so that it will be easy for you. You can take a broadcast if you wanted to take a broadcast. Okay, so auto broadcast, automatically it is going to treat the least size of the data will be broadcasted. And you're setting the partitioning type. Okay, so two partitions. If you have a broadcast, then automatically it is going to keep the same department data into these two partitions, and join will be happened in the particular partition. So round robin is going to be equally distributed the data across the partitions. Okay, so that is what you just keep in mind, how exactly it is going to do it. It distributes the data equally to all the partitions. You can control the number of partitions. You can control the number of partitions. Okay, example is if the data source is having 3 blocks, you can create 2 or more partitions. So you can control it. Okay. So if you have a 3 partitions, then the data is going to be distributed in different way. If you have a 4 partitions, then again it will be different approach, right? So different number of rows is going to get for each and every partition. That is about round robin partition. Now, when we can go for this hash partition? Okay, if we have a more volume of data, recommended to go with this hash partitioning. Okay, so for everything, for every record, there will be hash is going to be created. So hash means some code. Okay, some hash code is going to be generated for your record. Okay, for your hash column, you need to specify. So the column values to hash, which column you wanted to use to hash the data. Which column you wanted to use to hash the data, that you need to specify here. If I take a department number, then department number is going to be hashed. Okay, I don't have a department number here. Let me do one thing. I have it. Okay. Now, if you take a department number, what happens is, department number is going to be there in both of the tables, right? Left stream and right stream, it will be there. If you go for joining, Okay, I don't have a department string here, so I'm not able to show that. You will be selected it. Join column is department number from the left side and right side also department number. In the optimization, yes, taking 2 partitions here or 3 partitions, any number of partitions you can take it, depends on your requirement. And hash column is going to be taken here. Okay, so hash column is the department number. So which column we need to select the hash column is whatever the columns are participating to join the 2 tables, the same columns you have to keep it in the hash also. You can have a single column, you can have a multiple columns also in this particular case. So here, if you take this an example, okay, so how exactly this hash partitioning is going to be happen is just take out this to the bottom. Now I wanted to keep 3 partitions here. Just keep 3. I have a hundreds of partitionings here. I take this also. Let me duplicate this. So it will be 100 partitionings are there, and I wanted to keep a 3 partitions, right? All the data should be there in a 3 partitions, not in a 100 partitions. My data source is 100 partitions, but my I mean to say, when you come to the data factory, I wanted to bring them into the 3 partitions only. Okay, so I'll just going to adjust this, how we can handle it. Let's take out this from here. Something like this I wanted to keep. Three partitions are required, right? Okay, this is fine. Just take out this data. I have a partition 1. This is a partition 2. This is a partition 3. So 3 partitions you have created. 3 partitions you have created. How data is going to be loaded into this particular place is for this one you're going to have one more column is going to be added behind the scene. I need to bring this side. Side. This is correct. So let's say hash key. So hash key will be generated for this. And here also you'll be having hash key. So this will be taken care by your data factory itself. Data factory itself is going to taken care about here generating the hash key. We don't need to worry about it. So this is partition 1. Okay, so and this is partition 2. I wanted to treat this. And this is partition 3. Okay, so if I need number of rows, then I'm just going to increase them. Just understand there is a 3 partitions. So this data is going to be loaded, right? This data is going to be loaded. So when you load this data here, 101 is going to come. Employee name is A and department number is 10. So which column we are making a hash? We are making a hash based on the department number. That is what we are keeping here. The common column, the column which is participating in the join condition, that column we are making a partition. So here what happens is, just imagine H1 is there for or has, I'm just giving has 1 or has 01. I'm just giving some key here. Instead of giving a key, okay, so hash code will be there here. It will be uniquely identified. For this particular record, one hash key is generated. One hash key is generated. Then second record. Second record is not going to come to the same hash. Okay, because one hash key is generated for this. Some number is generated for this. Okay, so for this record is going to be happen. What it is going to be happen is, this is department number 30, is that right? This is going to store in some place. For this, it is going to have a one more hash key. Hash 00, hash 02. Hash 02 is generated. And the third record is come. The third record is having something is going to be generated. For this also it is going to generate some hash key. Okay. Based on the department number, right? So for this record, it is already having some hash key. If that hash key, for this value, we are having hash key, right? If that hash key is already available here, then ultimately this record is going to bring to this particular place. So same hash key will be generated for this. Same hash key will be generated for this. So do not think that department number wise it is doing. No. Whatever the department number it is, it will not care about it. It will create some hash key. If it is a new hash key, then it will go to the new partition. Okay. So let's observe here. This is coming department number 30. And for this one, I wanted to have a different hash key generated for this. You just imagine. Then it will go to the different place. Hash. Basically, for single value, you'll be having one hash key. Okay, but even if you have the same different values, but hash key is same, then I just wanted to say this hash key is 3. For this employee, there is a hash key, it is a hash key 3. So like this, it is going to create a hash keys. As many number of hash keys as required, that many keys is going to be created. For every partition, there will be one hash key. Okay, so this records is going to be aligned. Now this is 20. So 20 will be there here. You just imagine. Some hash key is available. Hash key 1. This record is completed. This record will go to this partition. You just imagine. So these are all going to be happen parallelly. 106 is completed. 107. Hash key is 3 here. Hash key is same. Okay, so and 109. Hash key will be this. Something like this. I'm just keeping randomly. So all the records are aligned into this particular place. For department table also, you are going to have a hash keys. Okay, so for department table also, you are going to have a hash key here. So department, I wanted to have even here also you are going to have a 3 partitions. So hash key will be there. Let's say, for example, okay, so I'm not able to show presently, I mean to say the data not presently accurately. I mean to say I'm not showing as expected, but I wanted to say you'll be having hash keys. So when you join the data, depends on the hash key you're going to join the data, not based on the internally it is going to join based on the hash key. It will go to that particular hash key. In that particular hash key, what department number is there? That department details are going to be joined automatically. Okay, so that is how it is going to do it. Okay, so in one hash key, you will be having multiple departments. When you have a 3 partitions, even 3 partitions are going to be happened for the department table also. Okay, so for hash key 1, how many departments are there? 2 departments are there. So 2 departments are going to be created. And for hash key 2, again, however it is the data is there, the same way it is going to have in this particular partitions also. Okay, so we cannot say practically this, but the data is going to be distributed based on the hash key. For every record, hash key will be generated, and depends on the hash key, it is going to generate. So it will not go to all the partitions. Here also, if you have a 3 partitions, it will never go to the 3 partitions to identify the record. Based on the hash key, it will go to that particular hash key only. Okay, so something like if you know about the medical shop, they used to arrange that medicines depends on the alphabet, right? So A will be there, B will be there. All the medicines which name starts with A at one place, okay, it will be there, right? So that is how it is. So if you see any medicine name which is starting with A, then directly can go to this particular place. But if you have a round robin, then you have to search in all the places. Or if you have as many number of partitions are there, that many number of partitions, like with current partitioning, you have to search in all the partitions. So that degrades the performance. But if you go for this hash key partitioning, then it is going to improve the performance because you can directly go to the appropriate place. You can go to a specific place to get the medicine. So that is going to give much more performance. So in real time, there is a more chances to use this hash key partitioning. Okay, so that is about it. So definitely you will be having a lot of confusion. You don't worry about it. Just give that example if you wanted to give the example, that medical shop example, so that they can easily understand this hash key partitioning. Okay, then dynamic range partition I'm having. When you have a dynamic partitioning, how you can do is depends on the condition you can do it. Depends on the condition, you can specify the partitioning here. What we can say, 2 partitions are there here. And you can specify partitioning here. Let's say, for example, dynamic partitioning is before the dynamic partitioning. Let me talk about this fixed range. Not fixed range. Let's go with the first key partitioning. Okay, so when you go for the key partitioning, what happens is whatever the let's say I wanted to create a partitioning based on the department number. Based on the department number, I wanted to do it. So when you go for department number, how many department numbers will be there? Let's say, for example, we will be having 10 partition, 10 department, 20 department, 30 department, and 40 departments. Total 40, that means 4 departments are there in my data source. So if I have a 4 partitions, I mean, it is a 4 distinct departments. This key partitioning is going to create a number of partitions. If you see here, I don't have any feasibility to choose how many number of partitions I need to take it. Okay, so when you go for the round robin, you have a feasibility to select how many number of partitions. In hash also you have seen how many number of partitions you wanted to go. But when you go for the key partitioning, you cannot specify how many number of partitions you wanted to take it, because this is depends on the distinct value of the key column. Distinct value of the key column is going to use to create a number of partitions. So if my key column is department number, so distinct values of the department number is going to be taken. And if I take a gender will be having male and female, right? Even you can also go for this option also you can go for that. But basically that it is having what we can say. You can fix the range. Okay, if you wanted to fix the range, you can fix it. When you go for the fixed range, even you can use the key partitioning also. Whatever the number of values, whatever the unique values are there for that particular key column, that many number of partitions are going to be created for the key partitioning. Okay, so if they ask what is the key partitioning, you can say the example. So depends on the distinct value of the key column, that many number of partitions are going to be created when you go for the key partitioning. Let me give a note here. Based on the distinct value of key column, number of partitions will be created. If key column, example I'm saying, if key column is having 4 distinct values, then it creates 4 partitions. Okay. And if you go for the fixed range, then you can give a conditions here. Whatever the number of partitions you wanted to take, you can take the number of partitions. And fixed range, you can see here fixed range partitioning will allow you to set ranges of your key values to provide balancing partitions. Only use these partitions if you have a understanding of the range of the values of your data. What we can say. Let's say, for example, I wanted to partition based on the salary. Okay, based on the salary, I wanted to do partitioning. Whatever the data is there less than 1 million, or whatever, salary will not be 1 million. Let me say something like this. If salary is less than 10,000, then I wanted to go for partition 1. Else, I wanted to go for partition 02. So second partition it will be taken. So this is a fixed range. You are making a fix. Whatever the salary is having less than 10,000, then bring that into one partition. If not, bring that into another partition. Because you are taking only 2 partitions here, so you have it only one condition you are going to specify. If that condition is filled, then it will go to the another partition. Let's say, for example, expression builder is like salary less than or equal to, I'm just taking 1,000 here. Okay. If I have a 3 partitions, then I can add one more condition here. You can add one more condition if you have a one more partition. If not, you can just leave it. Okay. If not, you can just give only one condition. If it is not, if it is less than, let me take this, less than or equal to 1,000, that will go into one partition, and else it will go to the another partition because we are having two partitions here. So if this condition is satisfied, that will be partition 1. And if the condition is not satisfied, then it will go to the another partition because it is fixed range. So you given only two ranges only, one range and second range. So one range you are giving less than or equal to 1000. So if this condition is failed, ultimately the record will go to this particular partition. So that is how this fixed range is going to work. And dynamic range, we are not sure about, basically, let's say, for example, in one day, less than 1000 is having very less number of records. Just imagine. For other things, we are having very huge number of records. Then this is not going to work. You're making balance, you're just going for the partition. Okay, so if you have very less number of records, then it's difficult, right? So if you have that kind of situation, then you can go for the dynamic partitioning. So dynamic partitioning is going to be taken automatically. Here also you can write the condition. You can choose the column. Let me take salary here also. So from too many values, automatically too many salaries. So it is going to bring one of the minimum value. One of the minimum value it is going to take and maximum value it is going to take. So I mean to say in the middle value, approximate middle value is going to be taken and max value will be taken. Okay, so middle value and max value. Middle value plus max value divided by number of partitions 2. So you're going to get some number. Okay, so let's say for example 3000 you got it. Okay, so if this value is less than or equal to 3000, this will go into one partition, and if this condition is failed, then it will go to another partition because we are taking a dynamic range. Okay, so dynamic range automatically, even if the values are having very less and if you go with the fixed range, if you have less, partition 1 is having very less and partition 2 is having very huge. In that case, if you have a dynamic partitioning, then it is going to give appropriate value to make your partition. So you're not fixing a value here. Okay, so fixing the value is not getting fixed. So here only it is going to be fixed. So this will be taken internally. We don't need to worry about it. But mostly in real time, recommended to use is hash partition. Okay, so if at all if they ask which partition you have used, you can say hash partitioning. Then if they ask about the rest of the partitions, you can just give an idea how we can set up these partitions. Okay, so this is more on theoretical that we are going to have it. Okay, so that's all about it. Now, if you have a questions, you can ask me. Unmute yourself.
Hi, Bhaskar. This is Venkat.
Yeah, Venkat.
See, coming to first part, right? Like, if we have any file in our on-premises means daily we are uploading from our on-premises to ADLS, right? So we can take it as on-premise, right? That
Yes.
file.
Yes.
Okay. So while we are uploading into ADLS Gen 2, but that file is not showing like blocks. Right.
That is the internal mechanism. You don't need to worry about it. You cannot see.
But
you cannot see you cannot see the data block wise in the ADLS.
Okay, but in that case, I executed the same pipeline to ADF, right? But that time that output was
because
loaded into blocks, right?
That's true because the output itself is coming as a blocks. Okay, that output itself is coming as a blocks. Because of that reason, it is having multiple part files. But here, when you upload the file, it is not going to show you multiple blocks. You cannot see that if you upload as a single file. If you have a doubt, you can do one thing. You have a context of database, right? From this database, there is a table called fact sets. Okay, just export the data into CSV file. .csv file. Okay, upload that file. Upload that file into where? Into ADLS. Okay, after uploading this file, how we can say, like which place you can see how many number of partitions are there. I think I can show it in a Databricks if it is a Databricks. Okay.
Okay.
So practical I can say, but here just go with the current partitioning and see how many number of partitions are getting. Try to join the data with join transformation by using the current partitioning. Okay, so which tables you wanted to join is take a fact sales one table, and there is a one more table called dim channel from the same place. Just take the dim channel table into CSV file and load those two files into ADLS, and then try to read the data from there and create a pipeline to join these two tables. There will be a channel key between these two tables. Common column is the channel key, and apply the joins and use the current partitioning. How many partitions it is going to show you? You just observe. Once you run it, in the output you can see how many partitions are there. I have shown you, if you remember yesterday.
Sorry, yesterday I didn't attend it, so that's
there is a Google symbol will be there, glasses symbol. You can open that. It will take you through that. How many partitions are there, or how many number of rows are coming. You can see that.
okay.
Hello.
Yeah.
Hi, sir. How are you? Like
Yeah, very good.
you said, like you need to join the two tables and apply the partitioning, right?
Because he is asking like how many partitions are not there, right? If you upload the file here in the
Okay,
input,
okay.
you cannot see in the input. Okay, in the input you cannot see that, but if you upload the more volume of the file, then read the data. Even if you upload here, you cannot see like a multiple blocks. It's an internal mechanism.
Yeah.
Okay, so if you want to see how many partitions are there, then just bring the data as a current partitioning. You can see the number of partitions.
Okay. Like I have one doubt. Like you said, like we need to you said we need to apply partitioning on the by joining two tables, right? Like
Yes.
where we need to apply? Like we need to apply in the join transformation.
That's what
Partition
I
should be
told you.
applied.
This
Okay.
particular thing will be there for join transformation, exist transformation, lookup transformation.
Okay.
Okay, for these
Okay.
transformations only we have a problem. Because your data has to move from one partition to another partition.
Okay.
So because of that reason, for this only we have a problem.
Okay, thank you.
Aggregate transformation, we don't have a broadcast because we are doing the aggregation in that particular place only. So you can use the only partitioning for aggregate transformation. In the optimist, you don't have a broadcast. So broadcast will come if you have a more than one table. Okay, any other question?
Oscar, one more thing from my side.
Mm-hmm.
We know in real time mostly we are using hash key, but practically I'm not aware of it. But while creating hash key partitioning, right? So which columns are best to take it?
Hash key 100% is it is join column.
Okay, only join column.
Yes. The columns are participating joining, right? So that column you can take it.
Okay. Sorry, actually, while explaining that hash key, right, little bit here, I face some network issues. So first part I understood like for 10 there is a hash 01, 20, I mean department number 20 there is a hash 02, department number 30 there is a hash 03. But again I see you changed like even department 20 also came under hash 01.
For every record, it is going to generate 3 hash keys. Okay.
Oh, for
Because you are
every
taking
record.
it, I mean to say, 3 partitions you have taken. So 3 hash keys will be there.
Yes.
Okay, it will give any hash key for any record. If you have 100 partitions, if you have different departments, it cannot go and create a hash key for based on the key column. Not like that. Okay, so it is
So
going.
it will pick randomly.
Yeah, it assigns whatever the hash key it wants to assign for that particular record. It will give hash key. That's all. So what value is there, it will never check.
So we can't verify also.
No.
It's a completely internal mechanism.
Internal mechanism. We can't see that. Even all these partitions we cannot see. It's internal.
Yes. And coming to that dynamic range, right? So you said like based on the salary. For example, we have 100 is the minimum salary and 1000 is the maximum salary. Okay.
Okay.
So 100 plus 1000 divided
No,
by
not
2.
100. Middle value.
Okay, middle means there will be exactly what it will take.
We are not sure. It's an internal algorithm. Okay. So let's say, for example, if it is 2 partitions, then it will go for min value plus max value divided
Okay.
by 2. If it is 3 partitions, then min value plus max value plus middle value divided by 3. Okay, if we have
Okay,
a 4
so-
partitions, it will behave how it is going to take that. So min and max is common. In between that, if you are based on the number of
Okay,
partitions,
okay.
it is going
Yeah.
to take it.
Yeah, got you, Bhaskar.
Yeah.
And yesterday, what you have covered? yesterday type 2 implementation.
Yes.
Actually, I didn't gone through that video as well. So
Yeah, yesterday type implementation.
okay.
Okay, so tomorrow I'm going to take the doubts, and I wanted to make sure all the people practiced whatever we discussed in the data factory. Okay, so from the next session, we're going to start talking about Azure Databricks.
I have one doubt that like.
Yeah.
Where on the side, sir? I have a huge file. Okay, I don't have any. So only single table, let's consider. That too CSV file. Okay, so,
File, where is the file? First person. If you have a file, where is the file?
so let's say that is in ADLS gentle.
Then it will be blocks. It will be having a blocks.
Yeah, file is in Blob. Okay, so while moving the data, I have choose cache partitioning.
Okay.
So and what suppose let's say file is very huge number of GB size. So since I'm not joining any conditions, I mean I'm not adding any other tables, I'm having only one file. So
in that case, you don't go for partitioning. Why you need to go for partitioning?
Because file has huge data, sir.
No. Say, you can go with the current partitioning, right?
Okay.
You can go with the current partitioning. As many number of blocks are there, that many partitions will be created here. Hash partitioning is required only if the data is moving from multiple partitions. You're getting my point.
Can you repeat this?
Let's say department table, department data is there in some partition, and your employee data is there in some other partition. Data has to be shuffled, right? Department data has to go to the employee partition.
Sure, yeah.
Okay, then only it is going to join the data.
Okay, let's say more than one table. Examples.
Whatever it is, the concept is same. The data has to move from one partition to another partition. That means if the data is moving across the partitions, then we require this partitioning types. If data is not moving across the partitions, then you can go with the current partitioning one.
Okay, got it. Yeah.
Okay, so in Databricks, we have a narrow transformations and wide transformations. Okay, so there also we are going to come across that kind of situations. So what transformations will be narrow transformations and what transformations will be wide transformations. Okay, so here also same. Wide transformations is lookup transformation and exist transformation, aggregate transformation. So wherever if you can feel the data is coming from different partitions. Okay, if that is the case, then you have to go for that. Let's say, for example, if we go here, single partitioning here, not single. If you come to here, Not this one, here. So whatever the data is there here, the data is available here on, right? So data is not, if you have only employee table, if you are not coming into this particular place, only one table, huge volume of data you have it, but you are doing some calculations, you are adding some columns, that's fine. If you want to add a column, you can add a column with derived column transformation. But this logic is going to apply for only this partition. And same logic is going to apply for this transformation. I mean to say this partition. Data is not moving from this partition to this partition. Individually, they are going to be executed. So we don't need to think about setting the partition. We can go with the current partition itself. If at all, if you wanted to take some data from another partition, if data is moving from one partition to another partition, then definitely you have to go for partition types.
We're done with ADF right now.
Yeah, mostly we are done. There are few things like auto scheduling and how we can create a, how we can automate. All those things we are going to say as part of the project. So few things are going to be there in the project stuff, like how we can use the ARM templates. We already saying how we can integrate with the Git repository.
Yeah.
That we are saying. Okay, so in the project, how we can use the data factory and Databricks, that we are going to see.
Okay. So next class, I mean, so you're going to.
So tomorrow I'm going to, I wanted to take some tests from you guys. So please attempt on tomorrow. Okay, so on the data factory, I'll give some tasks and you have to do on tomorrow. Okay, so those things will be theory as well as even task based also.
Okay.
Repeat again.
So, after ADF, R's class, so you're going to
Databricks.
Databricks or Python, not Python.
Of course, Python will be there before starting up the database. We are going to have it. Before writing the code, I'm going to take you through. Not like after completion of that, it will go. After setting up the environment, then we are going to see the basics of the Python. Then we'll see that. I'll take you through. You don't worry about it.
Yeah, thank you.
Okay. Okay, then I'm stopping here. We'll see on tomorrow.